This video will cover basic vocabulary for the foundations unit, and I will talk about how to format or effectively write the shorthand for each of these objects when you're using them in various problems. So the first thing we'll look at is a point. So if I plot a point on my screen, we can see point A. A point has 0 dimensions. On this screen, when I look at that point, I can see that it has a literal length and width, and that would be necessary for me to actually view it with my own eyes. But in the mathematical universe, a point has 0 dimensions. And the way you would write a point, or the notation you would use, is you're just going to plot a point and then write the capital letter that accompanies that point. Now, if I add another point to my screen, point B, and I want to leave my world of 0 dimensions and travel to point B, we can connect these 2 points. The connection of these 2 points can be described as a segment. We'll take that label off. So a segment stops at 2 endpoints, and the way to describe a segment with the proper notation is you would write both endpoints and put a little line over it. Okay? Or you could write it as B over A. Both are acceptable, but the segment stops at both endpoints. Now, this line is one-dimensional. When I think of dimensions, I like to think of how many numbers do I need to use to describe my location to someone else in that however many dimension universe, okay? So on a line, we have a one-dimensional line here. And the reason why it's one dimension, again, we can assign some numbers here. Let's say it's 0 and 5. If I told you I was at 3, there would be no question about where I am on this line. Okay, we would know my location. All it takes is one number to properly describe to someone where I am. So, again, when talking about number of dimensions, think to yourself, how many numbers do I need to use to describe my location in that universe? Okay? So we've seen a point, we've seen a segment, but now let's say that we don't want to stop at B. There's nothing that says we can't go beyond B. And if we do, what we introduce is a new vocab term, where if I have an origin at A and I travel through B, I have just drawn a ray. So a ray is going to be a one-dimensional object that has an origin point. It has an end point, and it extends forever in one direction. Okay, so that is our ray. And how do we describe this effectively? We are going to write our end point, and then another point that that ray passes through. In this case, it would be B, and then we are going to draw a arrow that points in one direction. And what we want is to write our end point first and our arrow pointing to the right, like so. Okay, so that is how we describe a ray. But just like we wanted to pass through B, we can also have passed through A in the opposite direction. So when we extend through both points forever, we have just drawn a line. Okay, so a line passes through at least 2 points. Okay, we need 2 points to describe a line, and it extends forever in both directions. And the way we label the line is choose 2 points on the line that it passes through, and we are going to draw a line over it with 2 directional arrows. Or we could do B over A. Okay, so we need 2 points to describe the line. And the reason we need 2 points to describe the line is because if I only use 1 point, well, there are an infinite amount of lines that pass through a single point. So by adding on another point, I know which of those infinitely many lines I am actually referring to. So we need at least 2 points when describing a line. Now, if we see there are multiple points on the same line, missed a few there. So F and D we will delete. But we can see that C, G, and E got added to this line AB. We would say that all 5 of these points are referred to as collinear. So when you see the term collinear, that just means all of the points appear on the same line. But what if we add a point to somewhere that's not on the line? So we introduce a new point D that is not on our line. Well, now we have to extend outside our one-dimensional line into a two-dimensional plane. Okay, so once we introduce a point outside of our line, we now introduce a plane. And a plane has 2 dimensions. And why is that? Because we only need 2 numbers to describe our location. And the plane that you're probably most familiar with is the XY coordinate plane. So now that we're in our 2-dimensional plane, if I want to describe my location to someone, say I'm right here, all I need to do is give them 2 points. Typically, we denote the direction we moved horizontally first. So in this case, I would have gone right 3 from this origin point. So we have an origin reference. And then I moved up 1. So if I give someone those 2 units, and they're aware of where the origin is, that is all I need to describe my location in this 2-dimensional plane. Now, if we have multiple lines in the same plane, we say that these lines are coplanar. Okay, so if multiple lines are in the same plane, they are coplanar. Now, you need 3 points to label a plane. So you might say, if I have point A up here, point B over here, and point C, right? We mentioned before, I need 2 points to describe a line, and I need 3 points to describe a plane. Because if I only use 2 points, there are an infinite amount of planes that pass through the line AB. So as soon as I introduce a 3rd point, in this case C, I now know which plane I'm talking about. And to describe that plane, you're just going to write plane and the 3 points that describe the plane, plane A, B, and C. So those are the basics for vocabulary that we will be using moving forward.